The idea is to talk about big data, right? So I must also tell you at least a bit about something called NoSQL, right? Maybe not in depth, but like many people asked questions also. So normally your RDBMS systems and all are built on the idea of SQL. You know what it is. I don't have to teach, right? Now NoSQL databases are the databases we use in the world of big data. So the simple definition is that this is a database which you use in big data. Why? Because Hadoop and all are not databases. Hadoop and all are analytical platforms. So what if you have a requirement where you need a real-time response for huge amount of data, like an RDBMS. So what is the primary purpose of an RDBMS? Client interaction. Somebody is interacting, they should get the output very fast, right? What is the same thing you want to achieve with big data? Then you will be using something called NoSQL databases. Now this is a very huge topic, and I may not be doing justice by covering this in half an hour or something. So somebody see that, then it's actually a very pretty huge topic. Okay, and there are too many things inside this. Okay, but just to give you some basic pointers, whenever somebody say NoSQL, there are 4 categories, and that is something very important. So you have something called a key value store or key value based, and then there is something called document based, then there is something called columnar, and then there is something called graph based. So 4 major categories are there in NoSQL. So first question you need to ask, if somebody is saying that, okay, I am using NoSQL database, which category? And they must be able to tell you one of this. There are more than 4 actually, and how many normal SQL vendors you know? Like normal RDBMS, how many vendors you know? So let's say Microsoft is there, right? Who else is there? Alright, like that, how many will be there? What do you think? Because of another reason, because NoSQL is not a mandatory concept. It's not like everybody should learn. If your company is using it, you learn. And in many companies when I have gone, they are using NoSQL databases. And the developers who are working on them do not have a complete idea, and that's perfectly fine. Nobody is asking you to sit and learn the complete NoSQL, right? So many companies use NoSQL. They know how to ingest the data, how to store the data, how to get the data, and some very basic idea how to connect it and all. That's enough. So it's not like RDBMS where you learn theory and sit and understand internal of RDBMS where the query is firing. That's not required. Okay. And it is not possible also. Practically, humanly, I don't think it is possible to learn all this. 225 vendors are there as of now. Okay. And majorly there are 4 categories. There are more than 4, but commonly when people discuss theory, they will say there are 4 categories. What is the basic difference in SQL and NoSQL? Let me ask you this. In SQL, let's say you are working for a production company. Okay. So you always do this, right? You will have a product table. You will create something called I'm just giving an example, okay? A product table. Then there will be a customer table. Right? Then there will be a orders table. Correct? So whenever you define your schema in the RDBMS world, you always do what? Normalization or denormalization? Normalization, yeah, depends. But normally you will normalize it, right? And the basic idea is that you represent your data in multiple tables. And whenever somebody wants to get some answer, you write a join query. Correct? This has been the foundation for every RDBMS. In NoSQL, there is nothing called a join. You cannot find the word join, first of all. And they don't follow this concept. That is the starting point of discussion. Now, this concept itself we can discuss for a day, right? So, basic idea is that you don't represent the data like this. Why? Because if you're having small amount of data, this is nice. But what if each table is 1 terabyte? then every time you have to do a join query, every time these three tables have to be joined. So that is not possible for me. So when I come to the world of big data, my data is big, my tables are big, I want to eliminate join operations. So what we do in NoSQL is that we create a single table. We don't even call it a table, something. We create a single thing where all these three things are present. Complete denormalization. There is nothing called normalization. This is the basic principle in which NoSQL is built, which also poses a lot of questions. I know how this is possible, what on earth are you talking about and all, but understand. No, that's what, there all the concepts are different. So in normal RDBMS, of course, first thing you are using a language called SQL. Here there is nothing called SQL. So there itself all the concepts that we learned are gone. Any concepts you learn is gone because no SQL. And so here another interesting point which people never understand is that if you are firing a SQL query, who is actually doing the job is the SQL engine. Meaning, I am writing a join query and the intention of the join query may be to produce top 10 records or something, right? Now, who is actually doing the hard work is the SQL engine. And that is why it is slow. In a NoSQL database, the NoSQL database will never do a hard job. Meaning, you will have an application. Have you ever thought about this? You open Amazon web page, right? You open Amazon web page, then you click on a product. The product page loads so fast. But have you ever thought? Millions of customers are accessing Amazon and millions of them are clicking on different product page. Did it ever happen to you that it takes 5 minutes to load a product page? No. And look at the amount of information you have in a product page, Amazon. The images, reviews, ratings, blah, blah, blah. Like, if I have to represent it as a table, minimum 500 columns will be there. Correct? Have you ever scrolled through a product page and see what amount of information it has? So what Amazon does is that Amazon uses something called DynamoDB. Amazon's NoSQL database is called DynamoDB. DynamoDB is a homegrown database. It's Amazon's own product. DynamoDB comes in this part. It's a key value store. DynamoDB comes in this part. Now, just to give you an idea, what key value stores does, they store the data in the database as a key and value. So, Amazon has, let's say, a table-like structure where there is a key and a value. The key is the product ID. The value is all the info. Meaning, when you're clicking on the product page, product link, that product ID is the key. And all the data is in the value. Now, when you click, it is firing a query on DynamoDB. Okay. Now, the beauty is, it is just dumping all this data. Okay. And what to make sense from the data, the application layer has to decide, not the database. Are you getting the difference? In RDBMS, the database has to decide what should be shown. Here, NoSQL database is just like storing and producing the result. They don't do any analytics. Meaning, in this ID, the value part, it will have a lot of things like maybe the images or the location to the images or URLs and everything. That will just push to the application. The application has to be powerful to display that. So your speed and all will come here, not here. Here also speed should be there for the lookup, faster lookup. But that's okay, because otherwise I should have created 10 tables for my single product and did a join operation every time somebody is clicking. That's impossible. I'm only talking about key value stores, okay. Others database also does similar, but this is the idea. So a lot of analytics did not go here. And accordingly, your queries are very simple. In fact, there are no queries at all. It is most like select queries. So it's like scanning the data. So you should be easily able to find the data, get the data. What to do with the data, your application has to decide. Not like SQL. In SQL, I'm like group, then order, then join, then sort. No, nothing. Give me the data. I'll do whatever I want. Now, who will do this once you get the data? That is your application layer. Your application layer may have anything. It depends. It may even have big data technologies or anything else or very powerful applications. And that can decide. Any type of, so there is no specific type of applications you can run. Any type of application you can run. Like from any programming framework, you can connect to NoSQL, right? Java-based applications and Python-based application, but your application framework has to be very powerful to serve the need immediately, right? And another thing is that this may not be reliable. When it comes to reliability, NoSQL databases are not 100% reliable. You cannot say. There are certain NoSQL databases which are reliable, which give preference to reliability. Not reliable in the sense, well, the reliability is actually built using something called a base. So like I said in ACID, here there is something called base. Basically available soft state eventual consistency. I think they just made it up to fit the, so ACID, the opposite of ACID is what? Base. Then they figured out what each letter stands for, right? So it is basically available soft state eventual consistency, basically. But that is a principle which guides NoSQL databases. When I say not reliable, these NoSQL databases are usually installed in a cluster. Very much like Hadoop, like 50 machines, 30 machines and all. So when some of the machines crashes, will your service be available or not? So that they can sacrifice. So there are some NoSQL databases in which you may get a connection timed out error, the query may not run, but they may have sacrificed that for speed. They may be really faster, right? On the other hand, there are some NoSQL databases which are very reliable, but probably the queries may be a bit slow, right? So you have an option. So these 4 categories, right? So they have options like whether that has to be reliable or unreliable, you want speed or you want consistency, etc. In simple ways, they don't follow SQL standards at all. You don't have ACID properties at all. Okay. And so where is the classic use case of NoSQL? The classic use case is that you are storing unstructured data first of all. So for example, if you are having DynamoDB, this value can be anything. I don't care. It's not a table, right? So the value can be anything. So I can store images or links or anything I want. Because what to do with the value, my application will decide. On RDBMS, that is not possible. I need my strict schema. Again, the schema is very loose in NoSQL. Many NoSQL databases do not support the idea of a schema. You don't need, because it's all like dumping the data and getting the data fast, right? The rest things will be handled. And so I was working with this Ola company, right? For one of their big data project. So Ola uses NoSQL database. They use a NoSQL database called Mongodb. Mongodb falls in document category. What is the speciality of Mongodb? Mongodb stores the data as JSON document. That is why it is called document-based NoSQL. So in MongoDB, if you search for your data, you can see that everything will be a key value, key value, key value. It's like a JSON document. That is why it is called a document-based DB. So I'm giving you a real use case, right? So what Ola does, what is Ola's requirement? If somebody is using their app, you start the app starts. Their only requirement is that a person should see the homepage of the app and how many cars are available. So if you're opening the app and at that point in time itself the app is not opening, it is getting stuck, you will hate Ola. But if you're able to open the app, see the cab, and if there are no cabs or the cab says I'll take half an hour, you are okay with it. You don't mind. Even if you call a cab, he cancels in the middle, you are okay. Because you are stuck. And you will either use Ola or Uber. But you don't want a situation where the app itself is not opening. So what Ola does, MongoDB is used to manage the connections, initial connections. Meaning, they have all the driver data, how many drivers are there, how many cabs are there with their location stored in MongoDB. And all the user data also. So when you're opening the app, your connection is actually hitting MongoDB. And since MongoDB is a distributed database, it can accept 1 billion connections simultaneously. No problem. And the queries are faster. So you're able to open the app, see the cab, and you're happy. But when you actually book the cab and when you pay money and all, MongoDB is not in picture. It's RDBMS. Because you cannot say that the money is halfway. You need reliability, right? So MongoDB is giving the best shot. In a worst situation, maybe you will not see any cab also. Possible. App may get stuck. But that's okay. Because I want, so there my requirement, business requirement is that I want a lot of customers to be served at the same time. Like even if 1 million customer open app, connection should be established. And they should be able to, so when you're opening the app, it's a query. You are searching for cab. So that query is handled by MongoDB. So since it is a distributed database, it is really fast. So the queries will work. You will see that. I have never seen any time when Ola app gets stuck. You can see the cars and all initially. Later it's a different story, right? So there they don't really care about reliability and all. All they care is the user should be able to use it. The same story applies to IRCTC. IRCTC was on traditional platform. Now they are either on MongoDB or Cassandra. You can see the difference if you log in. Only reason is this thing. But again, I'm telling you, I'm logging into IRCTC, right? And I want to book a train. We are in Bangalore. I want to book from Bangalore to Chennai, imagine, right? So I'm doing searching, connection searching, everything is nice. And when I search, there is like 20 tickets in third AC. Then I go to transaction. I booked. I'm in waiting list 100. There is no there is no relation between them because my initial search and connection and everything is handled by NoSQL, right? And the type of NoSQL IRCT uses, they sacrifice consistency. That is why if you log in, you will see 100 seats available, I will see 20 seats available. That's okay. Consistency is sacrificed, but connection speed is there. So end of the day, when your transaction happens, it is RDBMS. It cannot say 100 is there, 20 is there. It will look at the current seat status and book it. That is why you will end up in a waiting list even if you see what you say. So consistency initially, but later you will have no, RDBMS will kick in and it will say that your actual ticket is this. But problem solved, right? People are able to log in, right? So that's what I'm saying. Most of the use cases of NoSQL, it is kind of like a best shot, right? Where you are able to serve a lot of customers in real time, but there are NoSQL databases which are highly reliable, like Cassandra I was saying. Cassandra and all are highly reliable, not like this, okay? So you can even use it for transactions. There are many customers who use Cassandra and all for transactions. Not financial I'm saying, but very reliable and all. So columnar is where Cassandra comes in. Cassandra, HBase and all comes in. Graph is where Neo4j comes in. So in columnar database, they represent the data in a column format. That's why it's called columnar. In graph databases, the data is in graph format. Have you learned graph theory? So I want to build a model wherein I am analyzing all the flight data. How many flights are flying, how many delayed, how many cancelled, etc., around all the airports in the world, imagine. Now, I can create a table, no doubt about it. Airport name, airport, that's fine. But a graph database will be a better solution for me. I can have all these edges as airports and the routes, and then I can add attributes to the routes. I can say in this route, this many flights are flying, and why this flight got cancelled. So your entire data becomes represented in a graph format. And then you can write graph queries, not SQL queries. They will run on graph and it is much faster. So in certain use cases, people prefer graph databases to speed up. Twitter uses graph database. You have this person, then he follows someone, and he follows someone, he tweeted, he retweeted. So this connection is actually graph. The entire Twitter is actually on graph database. So if you represent it like that, the queries can be faster. Because normally if I create a table, the table length will be like 1 million row, 2 million row, 3 million. Graph can reuse it, right? So the relations can reuse it and the queries are much faster there. So they use their own format of queries and all. It's not SQL and all. Graph database, one classic example is Neo4j. Neo4j is actually the first company to come up with a NoSQL solution. They were the first company to start this thing. back in 2004 or something. The point is, you cannot practically replace RDBMS with this. You may be able to do it, but with very careful observation, right? Because these two guys have nothing in common. But they have invented a new category of NoSQL, which is similar to SQL. Now that is also possible. It's more like rows and table and asset properties and all. But apart from that, majority of them are like. And have you heard about this? What do you call caching? You cache the data, right? Redis is actually a NoSQL database, but I think it works on the SQL platform, right? Like you can Redis. There is a vendor called Redis. Redis has a high-speed caching platform. It's used for caching the queries. Okay, but that is considered to be a NoSQL database because it can be installed in a cluster and all. But Redis also understands your normal SQL analogies and all, I think. So there are some platforms like Redis which are also very much like SQL, but they fall in the NoSQL category.
What's the difference between big data analytics and normal analytics? It means only difference is like using big data products?
Yeah, so normally when you say big data analytics, that actually means that you are using the data is big data for sure, and the tools you are using. So like Hadoop or Hive or Spark, because these tools are specifically designed for big data. So when you say normal analytics, you can use any tool, right? So it doesn't really matter. But when you say big data analytics, you are either using Hive or Spark SQL, specific big data tool for analysis. And of course, the amount of data is also huge. That has to be there. You have to have huge amount of